Hello everybody, welcome back to our channel. In this video, I'm going to show you how to handle correctly exceptions within the Spring Boot application. Let's say you have an application that manages users' bank balances, okay? In that application, when a user makes a request to transfer a certain amount to a user, to another user, your application firstly check to make sure that the user that wants to make the transfer has sufficient funds to process this request. And let's say in the case where the user does not have sufficient funds to process this request, normally your application should throw an exception. An exception is an event that occurs during the execution of your program that disrupts the regular flow of things. So normally the users should transfer money to the other user that they want to transfer money to in your application, but because they don't have sufficient funds, an exception was thrown. Now, that is a good thing because it stopped an invalid operation from being processed. But for the user side, if you don't handle correctly that exception, they will be thrown with a huge 500 internal server error that they have no idea about whatsoever. You don't want that to be the case of your application. So what you would do normally is that you will handle that exception correctly in a way that the user of your endpoints or your service will have enough information to know what went wrong and how to fix it so that the operation can go on smoothly. This is what I'm going to show you how to do in this video. So if you're excited about it, like this video right now, subscribe to the channel if you're new, and let's start coding. Alright guys, so here I have a Spring Boot application already built. I'm going to walk you through the codes for you to understand what's going on. Now, in this project I'm using Gradle, and I'm using Spring Boot version 3 and Java 17. And also I have a few dependencies here. Spring Boot Starter, JDBC, Starter Web, and Lombok, as well as H2 for our database. So I'm not using any type of complex things here, just straightforward, simple things. Okay. I'm closing that, and I'm going to open the source folder, SRC, and in the SRC folder there are two folders, you already know, main and test. So I'm going to open the main folder and then go down straight to the resources folder. Now in the resources folder, I've changed the extension from application.properties to application.yaml, and also I have added a new file here called schema.sql. Simple file. I'm going to open it up and show you. All that I'm asking this file to do is create for me a table called accounts with these columns. Okay, straightforward, nothing crazy, nothing complex. Now I'm going to close that schema file and then open the application.properties. Also here in the application.properties, what I've done is I've set the server port to 9191. The default is 8080, and also I've changed the application name, or I've set the application name to exception handling demo, just to give you an idea of the application name. And I've configured the SQL init mode to always. That way the application, whenever it starts up, it will check for this file in the resources folder and execute it. Now also I've configured H2, because since we're using H2 as our database, configure H2 console, that we can see our tables and interact with them in the browser. And this is the data source configuration for the H2 in-memory database. Straightforward things, right? Now I'm going to close this and move out to the Java folder. Now here there are some quite interesting things. Here I have a few packages. I have a DTO package, entities package, loaders package, repositories, services, and web. These packages all have some unique classes that I've defined in their individual packages, because I like to have things organized. Okay. Now I'm going to start up by showing you what's inside a web package. I'm going to open it up and have just one controller. I'm opening this controller right now, so I'm going to close this one like so to have room. Now in this controller, I've annotated a class here with this require args from Lombok REST controller to make this class a RESTful web service controller, and then set the request mapping to account/account. And I have a few endpoints here that I've defined, and I'll map them to these methods. This, for example, post mapping /transfer is an endpoint that is connected to this make transfer request method. And this method, all it's doing is that it is grabbing the request payload, that is the data sent along with this request, converting it to this data type called transfer request, which is a DTO that I've created inside this DTO package. So I have a transfer request DTO here. I'm going to open it up for you to see. All we have there is a debit account ID, credit account ID, amount to transfer. Okay, so basically whenever in our system, let's say a mobile money application, or let's say some type of bank application, you perform transfer operations. Typically you send money from your account to another person's account. So the account that you are taking money from is going to be the debit account, and the ID is what we're requesting for here. And then the account that you want to send money to is going to be the credit account, and the ID is what I want here. And then also the amount that you want to transfer. Simple basic logic. Okay, now here I'm receiving that information, converting it to this type, and then all I'm doing next is sending back a response that we get when I call the service. So I'm passing that request to this service that I have here. I've injected this service here, transfer service, and there's some methods in that service. So one that I'm using in this case is the make transfer method. Let me close this so we have room. The make transfer method on the service class, and this is going to take this transfer request and continue the processing from there. Pretty straightforward. Now similarly for the accounts, credit account, this is basically adding money to an account. You just need to send this payload just like you did with this one. Send the request body with this credit request as a payload, and then I'm going to show you what is inside credit request. So credit request, I just need the ID of the account that you want to credit and the amount that you want to credit. That is add basically to the account. Okay, so now whenever we receive this request, I'm going to call the transfer service and then call this method on the transfer service, passing it this credit request, and it's going to continue the flow from there. The same thing for get account balance. We call in the service and then call this method, and then we grab in this account ID. So this account ID is going to be passed as a path variable, and then this is the placeholder ID. Okay, so I'll show you how it works in Postman if you don't have any idea about this. So basically we're just grabbing this value that will be passed after this slash and then map it to this type. So this ID now will be sent as an argument to this method on the transfer service, and then the flow will continue from there. Also for this get account, this is straightforward. We're just calling this method on the transfer service to get accounts and return them. So now this is all about the controller class. So let me move into the service class so that you see what happened next. So I'm going to close these DTOs that I created, and I'm going to open this service package. And in the service package, I have two types here. I have a transfer service, which is of type interface, and then this transfer service implementation, which is a regular class. So this interface, I'm going to open it. It contains the methods or the actions that we want to perform in the service, just the definitions of these methods, the signature, not the actual details implementation. So for example, the method to create to credit account, takes this argument, and then it also throws an exception. That is, I will explain that to you, when we see the implementation. And also string, it returns a string as return. When it's done processing, it also returns a string. So it either returns a string or it throws an exception. That is, some bad thing happen, error happen. Okay. Next one is to make transfer, where you can either make a successful transfer and return a response which is a string type, and then if the operation was not successful, something happened, an exception would be thrown. So basically this is the idea. So these methods, we've defined them here, and also here to get all accounts, we just return all of the accounts. And then here I have also another type, which is a DTO account, DTO, which is like representation of the user account. Okay, So if I open this DTO package, account DTO, you will notice that I just passing back the ID, the name of the person who owns the account, last name, their email, and then the balance that is in the account. Okay. Now I will close that, and we will go into the implementation of this interface. Okay, so the implementation is here, this class, transfer service IMPL. And in this class, you can see that I've annotated it with @service annotation, and also have this require axe constructor so that I can do dependency injection easily. And then in this class, I'm also injecting the repository, that is the transfer repository, which is in this package, repositories package. I'm going to open it up and show you what is there. This transfer repository interface is basically extending the CRUD repository and then passing in the type and the ID type as well. So this will give us, some basic methods to do some things. Like for example, the method to save or find by ID, and some really useful methods. So I don't need to recreate everything. I just extend this class and I have everything. Okay, so this is the repository. I'm going to close that. And then that repository has been injected inside of our thing, inside of our service implementation, transfer service implementation class, which is annotated with @service annotation. Now, whenever we implement an interface, all these methods that are defined inside this interface, we must implement. We must, give them logic, like the details of it. So that's why we have them here with this @override annotation. And for example, credit account is here. We have make transfer. I've provided the details, so I'm going to start by explaining them to you, but I want to start with this one at the bottom, the list all account, the get all accounts method. Okay. Now in this method, all I'm doing here is that I'm asking my transfer repository that I've injected up here. Okay, I inject it in this object transfer repository. So now I'm using it down here, telling it to find all my accounts, all account entities, that is all the accounts we have in our database. It's going to find them for me and then bring them back. When I bring them back, what I'm doing here is that I'm converting, not converting, but I'm just like passing it to a list, because this method will return for me an iterable and I want a list. So I'm just doing that passing right here so that I can have a list. Now this list, I'm calling a stream method on it and then mapping it, grabbing each account in that list and then converting it to an account DTO. So you notice that I'm not even using MapStruct or any type of complex mapping framework to do this. I'm doing it manually. So I'm creating a new account DTO, passing it this these values that are coming from each account from this list. Okay, and I set the ID, set the first name, last name, and then the balance as well. After everything, I convert it to a list and returns it directly as a list of account DTOs. So this is all about getting all the accounts in the database. Now the next method here is to get a single account. Okay, now if I want to get a single account, I need to have the account ID. And based on this account ID, I can now make a request to the transfer repository service repository that is going to talk to our database. Basically, I'm telling it, hey, transfer repository, can you get me the account that have this ID? Using this method, find by ID. So it's going to check in this database. However I do it, I don't know. The system is configured. That's the beauty of keeping things separated. So it's gonna do its own thing, check in its database what kind of database it's using. We don't care. It's gonna bring out the result. That's all we want, the result. So if it finds it, it will return it for me in this variable that I created here, ACC, short for account. And then if it does not find it, I will be throwing an exception. A new exception will be thrown. That is, an error will happen. So the regular flow that should go on will be disrupted. So basically, if I find the account that I want because I have the ID and checking the database, the account exists, we'll have the account. So now when we have this account, we can then return this account as a DTO, converting it as a DTO. So I'll create a new account DTO and then set these values to it. But if the account does not exist, then we have a problem. This part will be executed and an exception will be thrown. And when this exception is thrown, this part will not be executed, in the flow. So things will happen differently. An error will be thrown. Okay. Similarly, for the make transfer request, let me close this so that we have some room. To make a transfer, we will need a transfer request object. Okay, so the client or the user or the front end, whatever that is using our API, will send us a request with a transfer request as a payload. So as we've seen before, I'll open this again. The transfer request has the debit account ID, the credit account ID, and then the amount to transfer. Okay. Now, once we have this object, we will then use it to perform some operations. Firstly, we check if this account exists in our system. This account that we want to debit from exists in our system. So for that, we use this piece of code right here. And if it exists, it will return the value inside this debit account. So it will find the account and bring it back to me in this debit account variable. But if it does not, just like before, it will throw an exception. Error will happen. So hey, I have no idea what this account is. It does not exist here. So an exception will be thrown. Similarly, for the credit account, the account that we want to send money to, when the account does not exist, an exception will be thrown. If it exists, it will be returned. And this is the other test that we are given here. Here we are checking to make sure that the debit account, that is the account that is going to be money is going to be taken from, has enough funds to process the request. That is the amount that they want to transfer to the other account. If that amount is there in their balance, that they have enough sufficient funds to process that payment or that transfer. So this check will make sure of that. If the user or the account to be debited has less fund than the amount that should be debited or transferred, then that's a problem. We'll throw an exception. Okay. But if everything's cool, he has enough money, then no problem, no exception will be thrown. This part will be skipped. And then this one will take place, this action will happen. We'll then set the new balance for the debit. That is, we will grab the current balance and subtract the amount to transfer from it, and then save the debit. In the same way here, we will set the new balance for the account to be credited. So we grab the current balance of the account to be credited, and then we add to it the amount that should be credited, that is inside the request. So this is how that is done. After everything, we just save the object, and then everything will be balanced out. And once we completely perform all these operations, we return a response or message back to our caller, our client, telling them that, hey, your transfer operation completed successfully. That is if no exception was thrown throughout the entire process. Everything goes through correctly. But if there's some anomalies, and then things will happen, like for example, an account you want to credit from does not exist, or maybe the account has insufficient balance to perform the operation, then that's an anomaly. An exception will be thrown. An error will happen. Okay, so this video actually is concerned about how to handle these errors or these exceptions correctly, but I just want to show you right now the codes that we'll be using to implement that. Okay, now for the create account, same way as before, we just check if the account exists, then no problem, we can then credit it. We can grab the current balance and then add the amount to it, and then set the new balance and save it. Straightforward. So that's it for the service layer of this project. Everything here looks good and it should work correctly. Now let me see if I've covered all the things. All right, now we have two more packages here. We have this entities package. This entity package is basically our entity. That is the domain that we are working with. And then I'm connecting it to our accounts table that we defined inside of this schema. Remember from the start when I started explaining this schema, creating for us a table called accounts, and then this account is going to be mapped to this entity with these properties. Basically, that's it. And and then I'm gonna close all of these. I'm gonna close these classes and keep these ones. Okay. Now, the next one I have here is the Lotus package. This Lotus package basically is there to load things, when the application is starting up. So here I have one loader. I call it accounts loader. So this account loader is a simple class. I mark it as a component and then add this annotation to allow me to do dependency injection easily. I also here injected the repository that we created. Remember the transfer repository. And then I define a bin within this component, this class. And this bin is of type application runner. So meaning it's going to start immediately. It's going to run automatically immediately after the Spring context is fully loaded. Now, this when the application gets started, this is what it means. It means when my application starts, this will automatically run. So what I wanted to do is I wanted to create for me some accounts and save it in my database. Okay, so the accounts are here. I have account one with these properties. ID, I'm generating a random ID. Set the balance to $10 or 10 dirhams or 10 whatever currency. You get the idea. And the email as well, I set the email here. First name, last name, and then just build the object out and save it inside this variable, this account one variable. So similarly, we have account two with $10,000 or 10,000 dirhams or 10,000 whatever currency. You get the idea, and then save it. So here I have 20,000 for account three. Now, after all of creating all these accounts, I just save them all together in the database. So whenever I start my application, I will have these accounts available. Okay, so that's it for the project. That's all the code that we have here. Now let's go ahead and test it out in Postman and then look at the problems that we have and then how we can fix it. Now, to follow along with this tutorial, I have all these codes in my repo. I have the link in the description. So when you go to my repository and clone this project, I have created two branches basically in this code. So here, for example, I have the end branch and then the start branch. So the start branch here has all the code that we need, to get started with this project. Okay, there's no exception handling, codes part of this one. Just to get started, you have just this one that I've just explained to you. And then in the end branch, we have the complete code. Okay, we have all the project with the exceptions handling everything inside of it. So you can head out to the GitHub repo of this project and clone it now and follow along. All right, so if you have cloned this project already and started it like so, starting mine as well, what's going to happen is our project is going to run correctly, get started, everything, and the loader is going to get loaded and then create our initial accounts that we specify in the loader, these accounts. And now what I'm going to do is we're going to head out to Postman and test it out. So now our application is running. I'll come here to Postman and I'll send a request to get all the accounts. So this is the URL, http :// localhost 9191 and then /accounts. Okay, so if you look at this controller, we have that endpoint right here to get all accounts. Okay, so now let's see if we send this request, what we have. We have an account with just the 3 accounts that we loaded at the time of the application startup. So we have these 3 accounts here. We have account 1 with the balance of $10 or 10 euros or 10 pounds, whatever. And then we have account 2 with the balance of 10,000 and then account 3 with the balance of 20,000. Okay, so all of them have their own IDs. You can see account 1 has this ID, very unique, and account 2 has this ID and account 3 has this ID. Now the next endpoint we want to test is the endpoint to get an account by the ID. So I'm going to copy this ID, copy it like so, and come to this other endpoint. So here we need to pass in this URL and then pass also the ID. So I'm going to paste that ID that we copied and paste it in like so. So now I'm going to send this request, and voila, we have our response, we have our account. So this account has $10 in it. All right, so now let's try to add some money to this account. So let's credit some funds to this account. So for that, we also have an endpoint for that. Okay, so I'm going to paste the account ID here as the payload. This is the body of the request that will be sent to the endpoint for it to charge or credit an account. So we need to pass the account ID. I'm going to paste that same account ID here. This is the account ID of the account that has $10, this one. Okay, and similarly we have it here too. So now I'm going to send this request to add $100 to that account. So we click on send and we get a response. So everything worked correctly. We got a response saying user account successfully credited. Awesome, everything passed. You can see I have 200. Okay, things are looking good. So now let's verify by checking the balance of this account. So before we had $10 as balance, so now we're gonna send the request to get new balance, and here we have $110 as our new balance. So we were able to credit $100 to that account. That works fine. Everything's looking good. Now let's try the transfer operation. So to transfer, you need two accounts. You need an account that you want to transfer from and the account that you want to transfer to. So let's look at our get all accounts request, and we want to transfer, let's say, from this account. By the way, if we send this request again, this one would now be 110. It was $10 before. So I'm going to copy this account. We're going to transfer from this guy who has 110. Copy, come back here and put it there as the debit account. Paste it in and come back here. I want to credit to this guy who has maybe 10,000, this one. So now we have the two IDs of the two accounts. Want to maybe send $50, okay, from this 110 guy. Before he was 10, now he's 110. So he has enough funds to make a transfer of $50. Okay, so I'm going to send that request, and you have here a transfer operation completed successfully response. Now if you look here, we have status 201 created, that is things happening, everything is going on good. Let's check the guy new balance now and see. So I'm going to click here and click send. So his new balance now is $60 or 60 pounds or 60 Moroccan dirhams or 60 Liberian dollars, whatever. This is the new balance. This new balance is now going to be, okay, this is the new balance. Now let's check the balance of the account that we added money to. So I'm going to send this request to get all the accounts again and see if this account was credited in fact. So I sent it, and of course it was. Now you can see here that the new balance for the guy that we debited has 60, and the guy that we credited has 10,050. So things are looking good, everything is working fine. That is the normal way of things, right? But there will be scenarios where things will not work as we want. Bad things will happen. Let's say, for example, now that this user has a $60 balance, and then let's say he wants to transfer $500 to this other user. This operation is abnormal. It should not work. It should not happen. And we build our application in a way that when such things is detected, it will automatically say, hey, this is not good. It's an error. We'll choose an exception. Remember, we'll set an exception for that. So let's test it out and see. I'm going to send this request, and you can see that this request did not even process it. Automatically, our response come back to us with a 500 status code, internal server error, which is okay in a sense, right? For the developer that is writing the backend code, he prevented an invalid operation from being processed. But this is not the response you want to send back to your client, your users, or your front-end engineers. This gave him no information. He knows nothing about what happened. Maybe he try again. Oh, maybe that guy's server is crashing. He sent it. There's no response. This will bug him, and you should not write code like this. You should not write code that will give just this kind of responses. Okay, you should handle these exceptions whenever they are thrown, so that you can give accurate information to your users, your API users, or your clients. So now let's go ahead now and correct some of these errors and add proper exception handling in our code. Okay, so to start handling exceptions within our project, we'll add a new package in our main package. And in this one, we'll create a new package like so, and we'll call it exceptions. And inside of this exceptions package, I'm going to create a new class. I will call this class global exceptions handler. Okay. Now this class, I'm going to annotate it with REST controller advice, this annotation, and I'll also add SL4J to get that nice login implementation thing. So now in this class, we will have lots of methods that will handle specific exceptions for us. Okay, so these exceptions they're going to be errors to handle specific errors for us. I'm going to create another package in this exceptions package. I think it's a package, not class. I'm going to create another package, and I'll call this package errors. Okay, now in this errors package, I'll place all custom exceptions, all possible errors that can happen within my system. So I'll describe this, I'll create an exception for these errors, and we'll put them inside this place. Okay, instead of just returning or maybe throwing the global exception class, which we want to throw specific and custom exception for specific errors. All right, so these errors will be placed inside of this package. Next, we need messages. Okay, information that we will send back to our client as to what really happened. And this information, like for example, when you try to send money from an account that has less money than the amount to transfer, that is an error. So you need to let the user or the client knows that this is the thing that happened. You try to do this action, and this action happened in response. So now for that, I'll create a class. Okay, and I'm call this one error messages. Now this error messages class is going to hold like a bunch of static variables, public static final variables, and these variables will hold some information so that it's easy, like it's just going to be like a centralized location for all of your error messages. Okay, so for example, let's say you have an error message like so, public static final, and I'm going to call this one it's going to be of type string. It will be, let's say, default internal server error. Okay, and then we'll put the value there. So this one will be like for example, we could put the message there as an error occurred during or maybe let's say while processing request, something like this. Okay, I'm gonna to push this a little bit here so that you'll see. So this is an error message. So now in all parts of my application, I can use this class error messages dot this variable name, and then I can have this thing. So if I will have to modify this information in the future, everywhere in my application I use this, then will automatically get the new value. But if I just type in the information directly, it will be hard to to maintain in the long time. So this is where we'll place all of our error messages, custom error messages, okay? And then here in this package, we'll place all of our custom exceptions, all right? So now let's add another class inside this exception package as well. This one is gonna be the response that will send back to our client or our users when an exception is thrown, instead of sending them just a vague message that give them no clue. So we gotta describe that as well. So for that, I'll use Java records, and I'll call it exception response. Okay, this is the DTO basically that will go back to our users when the exception is thrown. So you can send in all information that you think that will help them understand the problem, but we're just going to try to keep things simple in this case. So I'll just send them just two information. Okay, I'll send them a string that will hold the message. Okay, that is the message of what happened, and then also I'll send them the status code. Okay, HTTP status, and then I'll just call the status something like this. All right, so these two attributes will be sent back to them, in a JSON format, so that they can have an idea of what happened. So now these classes are really, really important, and here we have to now define our custom exceptions. So let's go ahead now and define some custom exceptions. Now, let's create our first custom exception, and that will be, let's say, will be a Java class, and I will just call this one account not found exception, something like this. Okay, it could be maybe account does not exist exception. Now this exception should extend from one of the base classes, exception base classes. It could be runtime exception, it could be even the general exception class, but let's just extend from the runtime exception class. Okay, now this exception will show it whenever we try to find an account by the ID and that account is not existing in our database. So we'll show this custom exception instead of sending in exception like we've been doing. So now let's define some constructors for this class. So it will be account not found, like so, and then it will take a string of message, and then this message will be passed into the super. So this super will set the value to the the value inside the runtime exception class. Okay, so this is the runtime exception class, and it's also calling another class. It's extending, in fact, the global exception class. You see, so you see, and then this exception is extended as well, the throwable class. So you see, just extension. So these are the ones that are defined for us inside the language, inside the Java thing, and then but we want our own custom exceptions. We don't want to use this runtime exception because our case is is unique. So now I'm going to close these classes, and then we'll work with this exception that we created by extending this one. All right, so now we have this exception. We could create a few more exceptions. So let's create another exception, and you guessed it right, insufficient funds exception. So something like that, insufficient funds exception, something like this. So you're already getting the idea. These exceptions are the errors, right? Things that will happen, bad things that we expect to happen in the application. So it's going to extend the runtime exception just like before, and then create a constructor, and it will take a message, and then the super, and then pass in the message. So now we have two custom exceptions within our project. Now, next thing we're going to do is we'll create our handling the methods to handle these custom exceptions within our global exception handler class. Before we start handling our own custom exceptions, let's firstly take care of the system exceptions, like the runtime exception or even the default exception classes. when system related exceptions happen, like maybe database connection, or maybe some beans did not initiate properly. These kind of exceptions, when they happen, we want to handle them in a global fashion as well. Okay, so we'll create a method. I'll call this public. It will be a public method, and it will return a response entity, just like a controller would. A response entity of a specific type, and this type, it will be a type of object. Okay, so that we can have it more generalized, and then you give it a name. Okay, so I'll just call this one internal exception handler. Okay, so this will handle all internal exceptions in our this thing, and it will take as argument an exception, and then we'll just call it ex for simplicity. And then we will firstly log. That's why we added this SL4J thing here, so that we can have access to this thing easily. So we'll log an exception message. Okay, so we'll grab the message that comes with this exception. So we can do that by doing ex.get. We can do get localized message. Okay, and then we pass in the exception as well. So we will be logging the message from the exception as well as the exception. So this should not be info. We should log it because it's an error. Okay, so we log the error. An error happened, so log the error, not the info. Awesome. So this will correct it as handler. Now we have this method defined like so. Let me create a static variable here. So it's public static variable, not variable but string, final string, and I'll call this one default, just a default variable, default internal server error message. Okay, and we'll get the message from our errors messages. Remember, we created this error messages class, and then we have our custom error for that, so internal server error. So there we'll get that message from, and then put it inside this variable, and then we can now go ahead and use it in our application in this method. And besides, we'll be using this thing in a lot of places. That's why I am putting it in a global variable that we can easily call and manage. But I could also directly call these errors messages the default and then use it anywhere I want to use it. Now this method should return it should return for us our error response. Okay, now this error response, I want to create I'll create a private method in this class that will build for us that error response. So that method will return for us a response entity. By the way, it should be private so that it's only accessible in this class. It will return to our response entity of type object, and then I'll call it build error response. Okay, so this error response will take a string of s, or let's say message. It will take a message, and then it will take also the HTTP status. So I'll just call this one status. Okay, now with these two arguments, we can now return on response entity with the status of HTTP status that we have coming in as an argument. So let me close this so that we can have room. HTTP, no, not HTTP, but just status. We'll pass in the status there, and then in the body of that response, we'll pass in the message. But the message that we want to pass in, we don't want to pass in just a string. We'll have an object here that will define for that exception response. This exception response object. Okay, kind of like a DTO in that sense. So we'll create a new error exception response object, and then we'll pass into that the message and the status, because that's the two properties we have. All right, so now we have this private method. We can use it here, and we can just return this one and then pass in the argument that we need. So the argument, for example, in this case is the exception.get localized message, and then we'll also need to pass the error status code, okay, the HTTP status code. So it's going to be HTTP status code dot it's going to be internal there's HTTP status internal server error, this one. Okay, awesome. So now that we have this this information, we can now we have to annotate this method with the exception handler annotation. Okay, so exception handler annotation, and then we pass in the type of exceptions that will trigger this handler. So if you want to pass just one, you can just write the name of the exception directly, for example exception.class, like so. But if you have more than one exceptions that will trigger this handler, you put brackets around it like this, curly braces, and then you pass in the second one. So in this case, I want when this exception thing is when the exception is thrown, I want this method to handle it. Okay, and also if throwable, another exception type, throwable is thrown, I want this guy to also handle it for me. All right, but we are not yet completely finished. So after building this building our response, we want to check, right, before even sending in this exception message. I want to make sure that if the user or the exception that is thrown does not carry any message, I don't want to just send in a null as a message. I want the message to go there. So in that case, I'll have to do some check here. So I'll use the ternary operator. I will copy this class like so, and then I'll see if instead of doing if, I will just cut this one, and I'll use this objects dot non-null. Okay, and then I'll paste it in like so. So object of non-null checks for nulls. Okay, and if object of non-null is true, okay, if it is true, then I will use this message. Okay, that is if we have an exception message, that is an exception message was sent along with this exception when it was thrown, then we use the message that was sent along with the exception. But in the case where there was no exception, it is null, then we'll have to use this default one that we have up here, like so. All right, okay, now you get the point. Okay, so now that we have completed handling the exception for our general exception classes like exception and throwable, let's go ahead now and handle exceptions, our custom exceptions. Okay, so there's two exceptions that we have here. So we'll start with the account not found exception. All right, so for that we will define an exception handler and then a method like before, pu public. Let me just copy this to save some time, and then I will just rename a few things. I'll call this one account not found exception handler. All right, and it will take in an exception, and it will log the message, and then it will build an error response just like before. And we need also a message for that exception. All right, so let's say if there's no message, then we will want to pass in a custom message. So for that, we'll come inside our error messages here and define a new error message. So it's a public static final string, and then we'll call this one account not found error. So we can give this information as account does not exist in our systems. Okay, something like this. And then let me just do the other one too. For public final string, we'll just say insufficient fonts error, something like this. We'll just say you do not, let me just say account does not have enough fonts to process this operation, something like this. Okay, so here you can have as many error messages as you need within your application in this error messages class. Okay, so I think we are okay with these two. I'm just going to close that and come back to our global exception handler. So here I will just call the error messages that what's this one, account not found exception error message. And then, by the way, I have to annotate this with exchange exception handler, and then pass in the exception, the specific exception that this method should handle. So in our case, it's going to be account not found exception, and then you pass in the class like so. So this is the exception that will trigger this handler. Whenever this exception is thrown, then this handler will then grab it and continue and handle it in a proper form, instead of just sending a random message to the client. Awesome. So now we will do it for the second one as well. So I'll just copy the same thing and do a few modifications. And then here I'll do response entity. The name of the method, I'll change it to insufficient fonts exception handler, something like this. Okay, and it also takes in an exception. Then we'll log that error the message from this exception, and then we build the error response. So if this exception has a message, we'll keep the message. If it does not, we'll use the error messages that insufficient fonts error message, something like this. All right, awesome. So now we have defined two methods, three in fact. One is there to handle exceptions related to the exception class and the throwable class, and then we have another one related to our own custom exception that we created, account not found exception, and then this third one is related to the insufficient fonts exception that we created as well, this one. All right, so we have two custom exception, and then we're handling the global, or let's say the internal system exceptions as well. So we're handling them now. Now our exceptions are being handled correctly. So let's now go into our project and into our service implementation class, and we'll do some refactoring to reflect these changes that we've made. Okay, so I will come inside our services folder here, and then I'll open our transfer service implementation class. All right, so this transfer service implementation class, let me close all these other tabs so that we can have some room. And instead of throwing these general exceptions like so, what we'll be doing now is we'll be throwing our custom exception. All right, so we will throw here a new account not found exception, and then we'll pass in a message. For example, the message will come from our error messages class, and then that account not found error. Okay, So I need to import this class from the section public. Let me see what's going on here. All right, so this should be public, the constructor. All right, now we can work it out like that. I should do the same for the other one. Insufficient funds, the constructor should be public, because if you don't put public, it will default to package, and we don't want that. We want this thing to be available everywhere. So now it is public, and let me just close these two exceptions. I will come back to, I'll go back. Let me just copy the same thing because we use it in a couple of places. We just copy this. So everywhere we have that error, that exception for account not found exception, we just throw this specific exception that we created for that. And then our method we define, we handle it first. So this is here as well. We just replace this one too with that one, and let me close this so that we'll have room. And then where else are we using that? We're using it here. Okay, so everywhere we are searching our database for an account, we want to set this exception as well, because if the account is not found, then we have an error. So we want to throw an exception, and when we throw that exception, our REST controller advice class is that this global exception handler have a method that we define to handle that exception. That is the correct and proper way of doing it. Okay, so now that we have made that change, let's now come here and fix this one as well. So when we have insufficient balance and then want to make a fund transfer, we want to throw an exception, and the exception that we want to throw is going to be of type new insufficient fund exception, and we want to send a message. So the message will come from the error messages that insufficient funds error is this one. Okay, so now you see how everything is hooked up correctly, and you can easily modify this message just by coming in the error messages class, and then you make your changes here. So for example, this account not found exception, it is in fact repeated a lot in this class. In some classes, in some code bases, it will be repeated quite a lot more than this. So if you need to change the message, you have to look for that specific thing in a lot of places. But doing it like so, having static classes, you can easily change it in one place, and it will propagate to all the other places that it is used. This is a pretty neat approach. Now that we have set up our exception handling correctly, let's go ahead now and test our application again and see the difference. So now I will start our application like so, and let's hope everything works correctly. Awesome. So now everything is started up fine, everything is good. Let's go to Postman and test some endpoints. So now that our application is started, let's go ahead and call the endpoint that will give us all our accounts. Okay, so I'm going to call that endpoint by sending this request, and we have our accounts. All right, so we have the first account, second account, third account, just like before. Everything is good. So now I'm going to copy this first account ID. Copy this account ID. Why am I not copying it properly? All right, good. So now that I've copied it, I'm going to call this other endpoint that gets an account by its ID. So I'll send that request, and voila, it works. But now let's try to change this ID a little bit. So instead of 4, I'm going to post random 1, and then send this request and see what happens. This time around, we have an error. Account does not exist in our system error. You see, instead of receiving just that random message that we had before, and by the way, this internal server error too can be changed to a custom error as well. So we didn't modify that. That's why we're having this internal server error. But at least for the messages part, you can see that we have account does not exist in our system. So that way your client will have an idea of, okay, this is the reason why this thing is not working. So maybe I missed the account number. Let me fix it and send the request again, and now it's gonna work. All right, so let's fix that error message thing, status. So I'll go to our global exception class here. Instead of sending in the status like so, I will send in custom status. So for the global exception for internal state, this is the correct status code. And for account not found exception, is not the correct one. So let's fix that. It should be something like not found, which is logical, 404. And then insufficient font exception, they should be like let me see some exception that will let's say bad request. You could pick let's see if we have other things. We have forbidding. Let's just go bad request. Okay, so it's a bad request. All right, so now I save that. I'll restart my application, and once it's started up, I'll switch back to Postman, and this time around, let's try to get our account rather, and we have these accounts. So this is a new account ID now. This one is no longer valid, so let's test with the invalid one. And now we have 404 not found. So this 404 not found, everybody who program knows that it means something is not found. And besides, you have the status code in your message here, in your response body, and then you have the actual message as well here. Account does not exist in our systems. So this way, your users can have an idea of what happened in the system, and they don't have to be thinking about what did they do wrong. So to correct it now, here I'll just come and get a valid ID. Okay, I get a valid ID, and once I put a valid account ID and send this request, and now have my response. So let's test it as well for transfer operation. Okay, so let's say currently this user has $10. All right, let's say he wants to make a transfer to another user. Let me put this ID first, the debit account ID, which is the guy with $10, and then this one is the one that we will send to the credit account, and we'll put that his ID here as well. Now you have $10 in your balance and you want to make $500 worth of transfer to another person. That is a hilarious thing. So let's test it out and see how our system will respond. So we'll send this one. We have a 400 bad requests. So this is the response that we get. Before, we just had a 500 internal server error, which was ambiguous. You cannot figure out what went wrong. But this time around, you know straightly what happened. You send a bad request. Your account does not have enough funds to process this operation. Immediately you know that, oh, I don't have balance in my account to process this information. And these messages can be made as clear as possible, and your users will have ideas of what went wrong in your system. So that's it, guys. If you look here also in our logs, you will see that all these errors that were being thrown, they were being logged as well. You see, account does not exist, it happened, and it's in our log, and it's logged as an error. Similarly, when the account does not have enough funds exception was thrown, it was also logged. It was logged as an error. So you have these logs to know what happened in your system over time, and then your user will also have enough information to figure out what went wrong and how they can fix it. So this is the correct and proper way of handling exception within your Spring Boot application. So thank you guys for watching. If you enjoyed this video, kindly like this video, subscribe to the channel, share it with your friends. I have all the codes in the description of this video, so clone it, test it out for yourself, and happy coding.